Hello everyone, I hope everyone is good. So in this video, in my YouTube videos, you will see that I have upload 2 3 video regarding maybe systems engineering. So here is one of my live project that I've did in my last internship in my country, where I was I had a task to build system architecture, also a functioning mm, model for that whole electric um, motorcycle powertrain. So basically, that was a conversion project. So um, we needed to replace the ICE vehicle powertrain into electric powertrain. So basically, what we did is that we replaced the motor with that engine, and we replace the battery. I'm sorry, we integrated the battery, and we introduced a motor controller. So that's what that was the project. So the bike was already done, so I was assigned to check the integration gap, and I was about to test my own methodology here about the integration gap. However, in this video, I will share that in a system composer model, how did I model the Simulink model also. So basically the integration of the system composer model and the Simulink model all together. So here is our battery. You can see the battery. So from the battery, remember that all these interfaces are not functioning here for the MATLAB Simulink model. So both the Simulink and System Composer model are here. System Composer model are basically, which I have explained in my previous video. Um, System Composer models are basically to add your requirements and to design your interfaces and which component has what requirements, and a lot more thing you can check in the System Composer getting started or user guide mm, documents from MATLAB website. So I'm not going to dig into that thing. So so we can see that from battery, I mentioned the BMS information is going to the motor controller, because the motor controller has to know that what is the status of the battery uh, mm, charge status or cell balancing, etc., whatever it is. However, in this electric powertrain, it was not a big deal, yeah, because the BMS was inbuilt BMS, so it doesn't have like a lot more function and doesn't have an impact to all of our system actually. So we just did a non-functional interfaces here just to mention what are the interfaces going to motor controller. And of course, the voltage is very important. As you know, that from battery we got the voltage, the working voltage that will really, has an impact in energy management system in the whole powertrain. So yeah, so we incorporated the battery and we got certain voltage from there, and uh, the motor controller receives the voltage and it actually convert the DC voltage into AC one. So you can see that the phase A, phase B, and phase B is even a three-phase AC uh, AC control over the motor. The motor is actually a BLDC motor one. Uh, and we have here other two interfaces that are actually Simulink interfaces here, which is actually going through to the motor. Yeah. So I mentioned here like in the bracket Simulink, means the Simulink interfaces. Basically, the power interfaces are like phase A, phase B, and phase C. And we have the information interfaces here, like three Hall effect sensor, Hall ABC, which will actually project the uh, how to say the status of the armature inside the motor, or in other words, it will actually um, give you, if it will navigate the motor position actually. Yeah, so this information is important for motor controller because it will take certain strategy on its voltage generation and stuff like that with these interfaces, yeah, with motor and motor controller. And we have another one, it's a TPS sensor, which will actually connect with the throttle, because the throttle position is important, because motor controller will control the motor depending on these three information: the BMS and three Hall effect sensor information, and TPS, a throttle position sensor, right? So in motor we can see that these three phases are going in, and as I mentioned earlier, that phase AVC, this is a Simulink interface, and there's not actually it doesn't exist, just for the model I included here. And you have the output as the socket. It means there is a physical connection. Sprocket, actually, the sprocket needs to be adjusted with the chain, if you imagine in real life motorcycle, right? And the torque, of course, motor will provide torque to the torque will transfer through the sprocket with the help of a chain mechanism to the other driven sprocket in the rear wheel of that motorcycle, right? And you have a shaft, right? From the motor, you have a shaft, and which shaft is actually connected to the sprocket, and the sprocket is connected to the transmission chain and stuff like that, So if we look into the Simulink model here, we can start from here in the battery. So we have this BMS and the battery cell here. Actually, this one is the Simulink model, which actually you can see the Simulink SimScape components are here. Like in the battery, if we go inside the battery, we can see. So battery includes 72 voltage here. Yeah, supplying 72 volts, and you have a voltmeter and current sensor, which we say the ammeter, right? Which actually measure the current, right? Which is in series with the battery, and the voltmeter is in parallel, and we have an internal resistance here, as we know that every battery has its internal resistance. This is more of like a very simple model, and we just have to give a signal of power or voltage, whatever it is. Yeah. So we have a DC-DC converter, but I keep this DC-DC converter as it is. There is actually no conversion is going on. The power is same, because in order to fulfill the model, we need a DC-DC converter here. But I just keep the winding ratios the same, because uh, you know I just need to send the signal of the voltage, and actually in this model, the motor controller model is not very functioning. So I had to see what are the system level reaction of that vehicle. For example, the charging status and the total range that the vehicle can cover. What are the RPM status? Yeah, that's all. So yeah, so in order to finish the model, we needed a DC-DC converter here. Yeah, so you see the interface voltage is going, and the voltage interfaces we keep the Simulink voltage interfaces. Yeah, and as there is no BMS, actually in this model there is no BMS, and it's not in our interest right now, so I just keep it. The interfaces is not finished actually for the BMS stuff, because it's not in our interests, in system of interest. So if you go to the motor controller, we does have a motor controller, and it has a Simulink behavior, but it is not actually the motor controller it should be. So here's one cool thing, that you have to complete your project, and you have to see the system level results that are coming out from that system you design. So in that case, we're not designing a motor controller, but we will give the behavior of the motor controller. The signal is does matter. What you want to do, what you want to, what do you want to make your model to do. So in motor controller, what I actually included here is the strategy, right? The strategy and the speed command. So in the speed command, if you see the FTP75 drive cycle that I'm giving as an input signal for a standard drive cycle, yeah, and we have a speed to RPM conversion thing, because the speed need to be, you know, the command is actually coming from the FTP75 drive cycle as a speed, but I have to convert it to RPM reference because I have to give it to motor to decide actually. So that part is actually motor controlling part, but for the sake of the model, as I've mentioned earlier a lot of time, for the sake of the model, we have to consider a lot of things. So these signal is going to directly to motor, yeah. And you can see there's another thing that I have mentioned. The voltage interface ABC, it's not functioning. It's just as a symbol of that the motor controller does work, right? It convert it generates the three-phase voltage for the motor, but here since it's not actually functioning, so I just make a portrait of that to symbolize what is actually happening. And inside the motor, if you see the Simulink behavior, it's System Composer motor model of System Composer, and this one is Simulink model. So in the Simulink model, we see phase ABC is coming from the motor controller. Actually, it's coming from the DC-DC converter, and from battery to DC-DC converter. And in the sake of model completion, I just put these interfaces through the motor controller, right? So imagine the three-phase ABC is coming here. So you got inside the motor. Actually, if we go to the motor, actually this one is the motor and drive, and you have the speed controller, the RPM reference that are coming from the motor control, right? And in the speed control, you can see that we have a couple of Simulink model, which I'm not actually explaining right now here. So basically what it does, actually the RPM reference is coming directly from the motor control, and we have some calculations, and we have some mathematical function here which will decide, actually depending on the motor RPM reference, what should be the torque output, right? Yeah. So it's the T reference being the torque output that the vehicle does once from that motor. So the torque demand, it can be plotted here, right? You know, straight away from 0 to 10 Newton meter. Yeah. So um, so this place actually it processes the RPM reference to torque reference, and it gives torque reference. You can see this SimScape interfaces going through the motor axis. Yeah, actually, you have a couple of things that I actually did modified according to my model. Yeah, and this one is the motor RPM output RPM, which is here is really low, and it's not practical actually. So something has to be done with this motor. And we have here the scopes of power loss, battery charge, and I wanted to build a state of charge actually in percentage, but something fishy in this model, so I'm working on that. And this one is your reference speed, which is actually you fit according to your drive cycle. Um, in how to say, in the form of your RPM, and this one is your vehicle output, I mean the motor output. So finally we have the um, if you see the vehicle scope here, yeah, this one is the vehicle dynamics, and we have the speed and RPM output. Here we can see that. I'll move around a bit, yeah. So as I say, there's something fishy is going on there, so that's why the speed is really low here. Actually, this shouldn't be. So I had to check the model again. But I'm just sharing you about how did I model this and the whole model inside the System Composer with a Simulink model. And the more interesting thing is that you can trace your system requirement from here. Let me show you. Yeah, I often forget. All right, I think I have to go here. Requirement manager. Go to the requirement manager. Let's see. let me find out this one. Yeah, it's happened actually. If you're not actually working for a long time, then it's actually happened. So you have a couple of lists here regarding your interfaces, different interfaces. You have the information of interfaces and the model requirements. Yeah, let me see. I think this model, I had a model that I actually completely deleted the model requirement over there. So it's pretty sad thing for me that I had to work again regarding the model requirement. Anyway, so you can trace down the requirement from here, which is actually incorporated with the model, and you can trace your requirements, and you can make your test cases, and you can perform tests with System Composer and combine, model behavior with Simulink. Thank you very much.